All right, we are doing some extra examples on longhand division, and you can see that I have a quartic polynomial that I'm dividing by a quadratic trinomial. The other ones we did in the other video were just dividing by binomials. So I want to make sure I showed this. All the rules apply. We want to make sure that we have from the highest power to the lowest power and that we haven't skipped anything. And since I have so many terms in the top over these 3 terms in the bottom, there is nothing that they all have in common. So I cannot go in and reduce this. So I'm going to come in and I'm going to do longhand division. So as I do this, I want to make sure here's my power of 4, my power of 3, I have a power of 2, a power of 1, and a power of 0. If I'm missing any powers, I'd put in a 0x to that power as a placeholder. And out here, same thing, I want to make sure they're in standard form and I'm not missing any powers. So x squared plus 2x plus 5. Now we're going to do the same thing, we just have an extra piece. So what I want to find is to make my first term look like my first term. In order to do that, I'm going to take x squared times 2x squared, and that will give me my 2x to the 4th. So 2x squared times x squared is 2x to the 4th, and so I distribute that to all 3 terms, and that's how I bring in my trinomial. So that becomes a positive 4x to the 3rd, and then a positive 10x squared. Same rule, whenever I do the next step, I am subtracting, and I want to make sure that I am changing my signs. So I'm going to distribute that to addition of the opposite, which helps me not lose a sign later. Our first term should still cancel out, and then we go ahead and we add up like terms. I have a negative 15x to the 3rd, and I get a negative 2x squared, and I bring down my next term of negative 22x. So when I'm dividing by a trinomial, I should always be working with a trinomial when I start. And then I'm going to start again. I want to make this first term x squared into that negative 15x to the 3rd. So I'm going to multiply by a negative 15x. I'm again going to take that and distribute it. So I get a negative 15x to the 3rd. I get a negative 30x squared. And then a negative times a positive is going to be a negative, and I get 75x. I'm going to come in and subtract, and again change out my signs. So I am going through the same method. All right, the first term should always cancel out. And at this point, I am getting down to the end. I have a 28x squared. And make sure I'm looking at this right. I get a positive 53x. Drop down my next term of 144. Okay, I'm in my last piece of it, and I'm going to start again. I want to make x squared look like a 28x squared. So I'm going to multiply by just the 28 since I already have my x squared. So 28 times x squared is 28x squared. I have 28 times 2, which should give me 56. Keep the x. And 28 times 5, which gives me a positive 140. Now don't forget we're almost done, but we still need to take the time to change our signs. So addition of the opposite. First term cancels. It leaves me with a negative 3x and a positive 4. Okay, at this point, I don't have another term to drop down. I have an x squared, so I cannot multiply it by a positive exponent to get a negative 3x. This is my remainder, and that's what makes this different. Instead of having a single term remainder, I have a binomial remainder. So all I do, again, is I add it on. I want to keep the negative sign with the 3. So I'm going to add on my remainder of negative 3x plus 4 and divide it by my trinomial divisor of x squared plus 2x plus 5. So the final answer, 2x squared minus 15x plus 28. If I take this trinomial times my divisor, and then I add on the negative 3x plus 4, I will be back to my original dividend. So here's my remainder. Again, you always want to make sure you add on the remainder. Even though my first term is negative, I don't want the negative to go here because it does not distribute. All right, we have a word problem that we are going to look at. So here's an application problem. It's definitely in the world of physics, but we don't need to know physics in order to take care of this. But we have a Van de Graaff machine produces a very high voltage by using small but safe levels of electric current. One machine has a power that can be modeled by I of t. Okay, so the current is I of t, and that's t plus 2. And t has to be greater than 0, and it represents time in seconds. The power of the system can be modeled by P of t. Okay, so the power is modeled by P of t. Write an expression that represents the voltage of this system. Okay, so quick reminder, since we are not in a physics class, voltage is V, and it stands for the current and the powers relationship. So the voltage is found by P over I. So in function notation, V of t is equal to P of t divided by I of t. So in order to do this problem, I am simply taking P of t, which is 0.5 t to the third plus 6t squared plus 10t, and I am dividing it by t plus 2. Since I'm dividing by a binomial, I'm going to have to take the time and set this up and do longhand division. So I would make sure I'm not missing any terms. There's my 0.5 t to the third, my t squared, my t to the first, and I am missing a power of 0. So I'm going to go ahead and put a 0 as a placeholder, and then I'm going to divide by t plus 2. Working through our division problem, we're going to make our first term turn into a 0.5 t to the third by multiplying by 0.5 t squared. We come back and we distribute this to get 0.5 t to the third plus 1 t squared. Just like before, we're going to come in and subtract. We want to make sure that we change out our signs. This should always cancel out, and that leaves us a 5t squared plus 10t as we bring down our next term. And this is where we start again. I'm going to take that t and multiply it by 5t, so a positive 5t goes up here. 5t times t is 5t squared. 5t times 2 is a positive 10t. So we can see that everything matches out. When I come in to change my signs, I see that everything cancels and I'm zeroed out, and that'd be 0t, and the next term is 0. What this means is that 0.5t squared plus 5t is my factor, and it divides evenly since I have a remainder of 0. So the voltage over time, and remember t is time in seconds and it has to be greater than 0, is equal to 0.5 t squared plus 5t. Once you know the time in seconds, you plug that in and that will tell you your voltage. All right, we have another application problem, and it is talking about the area of a rectangle. And so when I see I'm talking about area of a rectangle, I want to go back to basics and remember that area equals length times width. And in this problem, they say write an expression. So we're not going to have an actual answer. We're going to have an expression for the length of a rectangle given the width is y minus 9 and the area is y squared minus 14y plus 45. Now, if I know that the area is length times width and I want to solve for the length, I'm simply going to divide by w and do that on both sides. And I now see that my length is equal to the area divided by the width. So I'm going to take my area, y squared minus 14y plus 45, and I'm going to divide by y minus 9. Now again, I'm dividing by a binomial, these terms do not all have something in common, so I'm going to go ahead and do longhand division. There is another option for this problem. We can factor the numerator, the bottom is factored, and we can cancel out any common terms. But since we're practicing longhand division, we're going to go ahead and do that. So we have y squared, we have a negative 14y at the first, and a positive 45. And I'm dividing by y minus 9. So again, I don't need any placeholders, and I have no placeholders out here that I need. So I'm going to go ahead and start. I'm going to take y times y to get me my y squared, distribute that, so y squared minus 9y. Come in and subtract with our division. Change out my signs by distributing the negative. This cancels, and it leaves me a negative 5y. Drop down the next term to be positive 45, and we start again. How do I make y into negative 5y? I'm going to multiply by a negative 5. When I do that, negative 5 times y is negative 5y. Negative times negative is going to be a positive 45, and we can see again in this problem that these zero themselves out. And so this cancels, it leaves me a remainder of 0. So the length of my rectangle is the expression y minus 5. Now, if we take a quick minute and we look at this, we could do this another way where we factor and we get y minus 9 times y minus 5 over y minus 9. And these two terms cancel, and I can only cancel because I have multiplication here, and so I can reduce that. And there is my answer of y minus 5. And so it would be, the length is y minus 5 units long. That means that y minus 9 is a factor of this trinomial. So if you want to rephrase that, y minus 9 is a binomial factor of this trinomial because it divided evenly and left us with a remainder of 0.